All right, so in your table, we did that little table part, okay? This little plunger right here is what stamps down on top of the table. So it's gonna come down and punch through, and this is the part we're gonna make first. And then we're gonna make one of these. Goes on the end of your handle, so it kind of holds on. Typically, this would be a threaded assembly. We're gonna do it as a welded assembly instead. But we're gonna spend some time on this. I'm gonna show you two ways to make this rack pad. Okay, so if you're at home working on this, you want to split your screen. I was gonna print, like I said, I really was gonna print this off, and I can't print a thing today. So let's take a minute and look at these numbers and get an idea of what we want to do. Now, this is all circular as we're thinking it through. It's got a chamfer on the bottom. It's got a fillet going around this space right here. We'll round this to it. And then it's got the stem. And the stem is going to stick into what is called the rack. And the rack is similar to what's on your steering column. It's a rack and pinion system. So what we're looking at then is, as we build this, how would this be made physically? What ways do you think you can make this? If I was to say, go build this, what would you do? From what you guys have done in your lives so far. What ways would you make this single part right here? Any ideas of how you make that? You can, any answer is a good answer. How would you make that? So I said, go in the shop and make me a rack pad. What would you use? How many took junior high shop? Did you have any shop classes? Are those all dead? You did? Did you do the pen assignment? Did you make pens?
No.
Did you magic wands? Did you use a lathe at all?
No.
Oh. All right, we'll have to do something. Gotta get you some stuff. Okay, so one of the ways you can do this is on a metal lathe. And that's where we take a chunk of metal, we spin it, and just like you would with a wood lathe, you carve it out. The second way you can make this is in a mold, where we make a mold, and if we're doing metal, we'll probably make that mold out of sand, pour the molten metal into the sand, and then we'll polish it up afterwards. Both of which should be a proper reuse of this. Both of which should be going about a little bit different process to build it, okay? So are you guys ready? Should we see if we can build this? Okay. Well, that's stupid. Okay, we're gonna have to do this the hard way. Let's go and get SolidWorks opened up, writing big. And again, if you are inclined and you would like to log into Zoom, you can.
Wait, so if we have a new version of SolidWorks at home, will it come over to this?
No, it won't. And that's the problem of trying to get the lab update. Yes, sir.
So my SolidWorks crashed, so it's like, oh,
Yeah, so did mine.
so.
Oh, it is.
Yeah, mine crashed before and then it opened up.
Yeah, it just, if you have to restart it, it just takes a minute to grab onto things in the morning. So try and give it a new go. So let it shut down and then restart again. It should grab the, okay.
Are we gonna do assembly when we have all the parts?
Absolutely. And then we're going to animate it. And then make a video of that animation. Okay. All right. So I'm going to try and make, we're going to make a new part file. And then once I get this opened, I'm going to make my screen a little smaller. And so I can put everything on one screen here. If I can be so fortunate. That way I can see kind of what's going on there. Okay, does that work for you guys? A little better? Okay, we're going to do it the wedding cake method first. Okay, wedding cake method says we're going to start on the top view. So that means we're going to go ahead and click on our sketch, start our sketch, and then click the top plane. So yes, I'm trying to get the lab updated so the version you have at home matches the version here at school. I've got the same problem with the architecture. So over the summer, they used this room for testing for all the kids that were doing testing because of COVID. And the room did not get updated like it should have been. So that's probably going to happen. We're probably trying to do that on a Friday. We'll see how it goes. All right, let's start with a circle. I don't want you to build a circle right on the origin point. Everything starts at the origin. So go ahead and draw a circle. Did you get rebooted yet?
I'm working on it.
Okay, good to know. And this is our larger circle. So we look at our drawing, and where is our diameter for this largest circle? What would that be?
I can't read numbers that far away.
Oh,
I'm
okay.
guessing 0.875.
0.875 is correct. Let me.
Oh, I guessed it.
You guessed it well. Okay. So we're going to do a smart dimension then. This is be weird. And make it 0.875. Okay. Now at that point, we're ready to do our first extrusion. I've got to move this over a little bit. Oh my. And it's going to extrude up how far? How high up does that 0.875 go? Oh.
0.6 times, or is that the valve?
So what you got to do is we're going up to this level right here. Do you see that? So that level right there. It's supposed to have a little fancy.
1.062 minus 0.81.
Yeah. So am I going to worry about that?
Subtraction.
Yeah. So what I'm going to do is just go into Zabutin here, and then go from the cursor, go into features, and then go right into my extrude boss base. And I know my total height is 1.062. I'm going to subtract from that 0.812. But I'm not going to do that. I'm just going to type it in, 1.062. Then put the minus sign, 0.812. There's no point in me doing more work than I have to if the computer will do it. Then I hit enter, and it comes out, oh, it's a quarter of an inch. How nice. Pretty simple math, right? But let SolidWorks do the math for you. Yes, sir.
Oh, never mind. It says restarting because my thing crashed.
Yeah, we're gonna have a little bit of that today, I think. Unfortunately. Okay, so that gives my height. Just go ahead and check that off then, once you get it. So we're gonna take that value, 0.875, and extrude at 0.25. Okay. How are we doing, buddy?
We're getting close.
Getting close? Do you reboot the whole computer?
Huh?
Do you reboot the whole computer?
Yeah.
Well, like I said, we're gonna do this twice. This is probably not the easiest way of doing this, but it does allow me to show you a couple of things you can do. Questions, because now you can actually ask questions, and I can read faces a little bit, at least eyes. Yes, sir.
What's up, man?
Well, so far, the sun.
I can say ceiling.
Well, that could fall any moment. It's 2020. Yes, gentlemen. Okay, so what you're going to do is you type in the value 1.062 minus, and then you put in the 0.812, and then enter. Bingo, just like that. Isn't that sweet? Then check it off. Yeah. Look at this. I'm able to see your screens without going through a whole nightmare thing. Okay. Where are we at? We got this all extruded. Oh, we just flat. Okay, so features.
Yeah, that was nice.
Extrude boss base. And right here, the distance is where we type in those values. So type in 1.062 minus
Share screen.
0.812. Yeah, that was a nice one.
I was looking the main
0.812.
guy. Whatever you call it. The host.
The host stuff. Yeah, that was crazy.
I should have banned you.
You could have. Hit enter,
I know.
and that hit your check.
I removed Andrew.
Yeah, that was the party.
Okay, so that's this guy here. Now. Okay, now we look. That looks a little large to you. Doesn't that look large to you?
That boy big.
So right here, this is only 0.875. That look a little better? We have some sketch there. Oh, yes. Okay. Anybody else get stuck, lost, bewildered, befuddled, or bemused?
Amused?
Bemused. My favorite word.
Does that mean amused?
It does. Cool. Everybody's got a kid. All righty.
Looking.
She's loading? Oh. Okay. Well, don't let her shoot too sharp. It is hunting season, so. She may take you out just for the fun of it. Okay.
Do you have any good stories about that?
Oh, my goodness. You're not old enough for those stories. That's what college is for. All right, so now we've got a disc. We can go ahead and tilt it around using your roller button on your mouse, so you can tilt it. What you want to do is be able to see the top of that. Okay, and now that can be a little confusing for you. So if you go to your view orientation and just click on the top view here, the cube. Man, this is all messed up. Some sub got playing with my settings. Okay, this is the top view. We're going to make another circle on the top view. Okay, now typically I would end up going into 3D and drawing this, but we're going to be okay right here, I think. Now, what's the next size circle that's on this? You see how that comes? Yep, the 5/8. See how that comes down? And there's our next circle. Okay, we good? All right, let's do a circle then. So new sketch. This will be the first time we've done multiple sketches on a part. So do a new sketch and then activate your sketch. Give the yellow box. It says take a minute and think about it. So if it's if someone gives you a yellow snow cone, don't you always pause and think before you eat it? No. No?
It just
Yes.
tastes good either way.
No, it doesn't. One's salty and one's
Have you
sweet.
tried one?
We're not gonna go down that road. Babies was a tough time to grow up, man. There wasn't any rules. All right, so I'm gonna pick on the surface of my top plane. So I bring it out. Notice my cursor's changed a little bit. It's got two blue squares. It's asking me to pick a surface or a plane to draw on. So once I click on it, I'll get a new origin point. Brand new origin point. Now we're gonna do a new circle, add that origin point, drag it out, and now we're gonna do a smart dimension to size it. So kind of getting this routine, sketch, draw. Now in the announcements, and I'll go back over those before we leave today, what's gonna happen is in the Mechanical 1 class, you're gonna get the sketching you're doing now, that grade will go there, and the 3D model will go into the second class. And that way I can move these two classes along at the same time and get everything covered. It just works easier that way. The nature it is. So the smart dimension is really important here. Select the edge of your circle and make it 0.625. Pretty good looking circle. Okay, now we've got to figure out the height of this one. We're going to do the exact same thing we did. I'm just going to tilt it so I can see what's going on. Again, push the roll button down and then push it away from me a little bit.
What's the dimension on it?
0.625. It comes from this value right here. Yep, right there. Try something here. All my tools are not working. I'm going to put a little plug in for you guys here a little bit. I'm one of the advisors for TSA, the Technology Student Association. What that is, it allows you to create projects to compete with. Competitions are right now for the state are kind of virtual. We're looking for officers. If you want to be an officer in that organization, that's a good thing to put onto your resume. For somebody to go down to SUU, that's one thing that bumps you up to an extra $500 on your scholarships, which is a really nice thing to do. There's a leadership competition, leadership training. It's gonna be a virtual training in October, and if you're interested in that, just zip me an email. But the big thing about that is in March we have the state competitions where you're going to design. Well, there's 86 different competitions you guys could do. And we'll go over those a little bit more in detail probably next week about what those are. There's some pretty cool things that you can do there. Then if you win first place in the state, the national competition is in Orlando, Florida. And the state will give you $300 to go. And then it usually costs you like $600 for a week in Orlando, plus food. So it's a pretty good deal. The state basically covers your airfare, is what that works out to be, and a big chunk of your hotel room. We usually stay in a 5-star hotel, which is pretty nice. Yeah, except the name of the hotel is kind of weird. We almost always stay at the Marriott Gaylords, but it's just what it is. All right. Let's go ahead and do our next extrusion within the same process. The total height from the base to the top is 0.812, and from the top down to where we're going is 0.562. So when we do our features and our extrude boss base again, we then put in the mathematical equation because it's just easier. 0.812 minus 0.562, enter. Oh my gosh, it's another quarter of an inch. You think someone planned this crap out? Huh. Enter.
Come on. Wait, minus what?
Minus the 0.562. Okay, now we've got our little wedding cake going on here. Yay, little wedding cake. We now can do our final little spindle. Let's call it a stem that goes up from the middle. I'm going to leave it in an isometric view here. Isometric just means I can see multiple surfaces at the same time. Rather than going to the top view and seeing just 2 big circles, I can see where I'm at. Then do another sketch. Activate the sketch and select the surface I want to draw on. Right here. There's my little origin right at the top of the cake now. We'll then do another circle. Woohoo! Guess where? Thank you. I was almost to hold my breath and I was going to die. So we draw a little circle out. The diameter on this circle, oh, it's a limit dimension. It cannot be smaller than 1/4 inch, but not larger than 0.251. That means that this stem goes into something else. Okay? Now, what that means is when we make a hole in the bottom of our rack that this goes into, that would make it the largest size the hole can be. So that means that what goes in the hole needs to be as small as it can be. So we're just making 1/4 inch. Okay? So we make whatever goes into something, makes that the smallest possible, and what it's going into is the largest possible. That way, when things expand and contract with temperature, they don't bind up and get stuck. Yes, I can help you. Yes. So we're going to smart dimension this, make it 1/4 inch, and then you guys should be able to figure out what the extrusion is. How high up does it go? And our value here is 0.562. And there's a little stem. Great wedding cake, right? Okay, we have 2 things to do to this. One is that the bottom of the rack pad is this chamfer. Okay? Nice, pretty little chamfer. And then on the top is this convex, fun little 0.312 radius. We're going to do the chamfer first. Okay? So we're going to move along here to our fillet tool. Hit the down arrow and change it to chamfer. And our chamfer is like almost all the chamfers on the arbor press. It's a 1/16 of an inch with a 45-degree angle. Okay? So down here where the distance is, change that to 1/16 of an inch, 0.0625. Or you can put in 1/16. SOLIDWORKS is pretty ambidextrous. There's a big word for you. It'll take it any way you want to give it. Once you have that value placed, all you have to do is bring your cursor over and select the bottom edge of your wedding cake. Boom. If you have your full preview on, you can see what that's going to look like before you do it. And then we just check that off. That part was easy. The next part's just as easy. Instead of using the, wait, everybody there, did everybody get that done? If not, raise them really high, but all 5 fingers, I don't want any one finger salutes. It's still in the featured ribbon. We're gonna do a fillet. And I'm gonna have full preview on. I want the edge that's between the 2 tiers. So this edge is right between the top cake and the bottom cake. Click on that. Now, if your radius is too large, you will not get a preview. So you won't see anything until you adjust what the size will be. So we want that fillet to be 0.312. And once you get the right size, it'll give you the preview of that scalped edge there. Okay? So if ever you have the full preview on and you can't see a preview, that means the size is too large for what you're trying to do. So right now, the distance here is 1/4 inch up, but I only have less than that going this way. That's why your size is kind of important on there. Hit your check mark, and that is the rack pad. Okay? Easy peasy, right? Lemon squeezy. Okay, you can go ahead and save this. The next one you do is going to be a little more complicated. Okay, I said this is your hard one, but yeah, this is one. So,
What is this called?
rack pad. Yep, say this is a rack pad. Now, you can choose to keep this one and use this one for your final assembly, but I want to use this because some of your assignments this week are going to ask about another command that we need to learn about because we haven't done it yet, and we need to do it. So if I look at a drawing like what I have here on the rack pad, there's a center line that goes right through the middle. That's a dash. Well, it's a long, short kind of dash line. A center line in mechanical engineering means 2 things. 1, it means it's round. And 2, it means it's symmetrical. So you have to look at your other views to determine the roundness of something. So if I look up above, I've got 2 center lines that create the center point of the top view. That helps me understand this is a round object. But because it has a center line that's symmetrical, I can do a few things with it. Just like our base being symmetrical, we just mirrored it over. If I want something round, I can't do a mirror, but I can do a revolve. So I basically can spin it. And that's what we're going to do with this next. We're going to spin this around, and so we have at least so I understand what revolve does. This is a good one to start with, and as we keep going, we should probably, hopefully, get maybe 4 drawings done today, which means we'll go back to the throwing star. And the girls are going, I don't want to do a throwing star. That's stupid. Throwing stars can become Christmas ornaments really quick by punching a few holes in them and make them into Christmas stars and Christmas ornaments. So we're going to actually do that. I've done, in the past in this class, I've done things like cookie cutters, and we 3D print our own cookie cutter, which is kind of cool. We might be able to maybe make some cookies. I have to talk to the cooking people. Okay, so we're going to do the exact same part again, but this time we're going to do it with revolve. Okay, so you know what it's going to look like. Did everybody get this one put together?
Yes, sir.
Absolutely perfect. Okay, so go up and start a new part. And we're going to do this one on the front plane. Okay, so start a sketch, activate the sketch, and select the front plane. Now, in reality, it doesn't matter really which way you start on these planes, but it helps you to keep things oriented when we assemble them, if you think about how they go together. And that means you've had meetings, you've talked about it, you work with the other design team. Rarely in the industry will you work alone. Okay, you just don't. You always work with a team. Yes, great one. Okay, just hit the X and pick out. Or if you're in the sketch all the way, like you did top. Okay, so using the top plane, just come here and exit the sketch. And then click on it again. Then rotate it and get to where you get the front place. It'll change your sketch number, but that's not a big deal. Okay, it'll just change which number sketch you are. Okay, so because we're going to do this, I want you to start. We're going to start with a center line. So go up to the line tool, hit the little arrow, and we want to change it to center line. Okay, did everybody find that? Click on center line. Then you're going to take from the origin, just draw it up. The length of that line doesn't matter. Okay, that center line doesn't matter. Somebody draw a center line. I am going to walk in the back of the room and see how you screen. Because I think I need to do that. Okay, my friend. You probably have a hard time hearing this mask. So we need to make sure you stay visible, okay? There's some things that we can do at the center line now that make life really easy, okay? So remember when we make the tiered cakes, it's basically a stair step. So that's what we're going to create, okay? Which side should I start on, left or right? Which one do you want me to be?
Right to left.
Right to left, okay. So I'll be working on the right side. We're going to take a line tool. Do not come onto the center line. Come up the side. Find the origin of kind of float with that little blue line so it floats out there a little bit. That way you at least know where you're at. If we miss it, we can fix it. Okay, it's not a big deal.
How do you get that dot blue line?
Float over the origin and then pull it out. And then just draw a line up, line over, line up, line over, and a line up. Just like that. Boom, boom, boom. Easy peasy. Okay, so we got this little stair step thing going on. So boop, 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 boop. Let's get a thumbs up if you got it. Cool. I love thumbs. The only thing that separates us from
Monkeys.
no, because they have thumbs. Actually, they could probably do this program. So thumbs down, right? All right. Now we know some dimensions on this already, but we have a center line. So I know some of you, like in the back corner, you kind of moved ahead a little bit. I want to show you a couple things with the center line that are kind of sweet. I know that this line and its counterpart on the other side would be a total of 0.875. That's this guy right here. Okay.
Divide that by 2.
Nope. This is where magic happens. I like magic. So hit Smart Dimension. If you click on your center line and then that lowest vertical line and you pop it over. So watch the screen a minute. That's what you'd want to do if I cut it in half. I don't want to cut it in half. That's more work. Why would I want to do more work? I'm a freaking American. I want the easiest way to do the job possible. Okay, so I pop it over. It's in a mirror where it would be on the other side. Okay, so then I put in the actual value.
Okay, how do you do that?
Oh my goodness. It's always the white kids that have to control you guys.
Oh.
And yes, if that's racist, I don't really care. All right, Smart Dimension. Start with the center line. Then select the vertical line.
What if you said 0.88?
So then it's rounded, right? We didn't change the rounding settings. Pop it over to the other side. So it just pops over. Okay. And then put in 0.875. And it will round because we didn't change the rounding on this one. Remember, we had to do it the other day. And sometimes I will and sometimes I won't. As long as you're typing in the correct value, it's in there. Okay, it's in there. Anybody have a problem with this part? Okay, let's do the next tier up. Same way, we're still in the Smart Dimension. Notice I'm doing it all in one sketch instead of 4 or 3. So center line, next vertical line, pop it over, make that one 0.625. It'll come up 0.63, that's fine. And now our third one, center line, the third vertical line, pop it over, 0.25. Okay, just boom, 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 just that quick. Now I'm going to start down here at the bottom, and then come around and help everybody. What's the height of this line? What's this height? 0.25, because you kept it simple. What's the height of this line? 0.25. Oh, it's already there. I'm so good. Okay, and then the other one, we have to go a little different. Okay, so let me get you out at this point, and the last one's a little different. Oh no, you over-constrained it. You tied it up and it can't move. Oh. Okay, so get off that one. Make sure you get just the line. Okay, so you're going to just try to do horizontal at the same time. 0.25 to work with. Okay, and if you notice, I'm already kind of sloping downhill here. My endpoint here doesn't match my origin, and that's fine. I'm not worried about that right now. I want to get my lines all the right height. Okay, and my total height is 1.062. There's actually 5 in there. We're not worried about it. So to do a point-to-point dimension, as I come down here, make sure you get the orange dot at the end of the line. So I want the orange dot at the very bottom of the line. Then select the orange dot at the very top line. And then don't go at an angle. That'd be bad. Very, very bad. Bring it straight out to the side. And that's 1.062. Okay, and that sets all my heights. Now I do need to get things kind of capped off, if you will. So we're going to fix our caps a little bit. These dimensions now should have us fully constrained. I have 2 blue lines left. I'm okay with that. My center line is a little short. I'm going to fix that. I'm going to start with a standard line, just a regular line now. I'm going to go from the origin to my bottom point, and then force that to be horizontal. Yes, sir. So we get this bottom one set to horizontal. We want to do the same thing at the top. So I'm going to connect my center line to the top piece, the top point. Force that horizontal. That just stretches that center line. That's all it's doing. It's just constraining it, so it's all set down. Now, the reality is, here's the next step. I know I've got a fillet right in here. Right from this top to this point, that's where it rounds off. Their sketch has a fillet tool in here. So it's called the sketch fillet. If I go and put in my value of 0.312, the sketch fillet, yeah, it's right below the ellipse. Right below the ellipse. And if I select this vertical line, it's already, wow, you silly line. Make sure your other lines aren't selected. Bad news. So I do the sketch fillet. It's set to 0.312. This vertical and this horizontal, it's going to air out every time. It won't do it in this mode. It did just fine when I had the 3D model and stacked them up. But because of the limited amount of data that's in the drawing, because it's only 2-dimensional and not 3, I can't go on, okay? Now, some of you might have got that in there. Did you get yours forced in there on your fillet? Yeah. So again, you can try with a different line, but you're using up this entire line, and that's why it shouldn't let you. If you're able to get a fillet in here, that means this horizontal is too long. Your dimensions are off somewhere. Okay, so we're going to do the new command, and then we'll add the chamfer and the fillet just like we did before. Okay. I could put the chamfer here, and I'll show you that so you know how to do that. The chamfer's inside the 2D fillet. There's a chamfer. Set the value to 0.0625. Select the 2 lines at the bottom, and it's still going to say So yeah, there's some loose constraint. It's going to do this. It's going to mark them out there because I'm taking away the endpoint that was used for dimension. And that's this point right here is now an asterisk because when I chop that corner off, I remove the data that was used to hold it together. It's still there. I'm okay, but it's to say you kind of unconstrained yourself a little bit. It's just a warning. It still works. But if that bothers you, I can Control Z and put it back. It's not a big deal. But when I chop this corner off, I'm losing this dimension and this dimension's anchor point. And it's to give you an error, a warning. It's not really an error, it's just a warning. Okay. So if you want to leave that off, it'll make it a little easier for you, a little less errors. But just understand what the warnings are saying so you don't panic on them. A lot of times you say, hey, you're using up your endpoint. It's going to throw off your dimensions. Are you okay doing that? Yeah, sure, fine, I'm okay. Here's the new command. You ready? So whether you chamfered it or not, here's the next one. Go to Features, Revolve Boss Base. I know, you're okay. Now, it should show you this preview right away if everything's well, okay? So this is a really important aspect of being able to do your lightsabers, is being able to do a good revolve and understand what's going on with it, okay? Now, if for some reason you decide to do a different line and you pick a different line, you're going to get a different result.
Whoa.
So I'm going to clear that out again, pick a different one. It won't do that. Well, I want to do this line. It did fine here, but not here. What's going on? Actually, there's too many negatives. So if I'm revolving about this line, then everything above the line is a positive, everything below the line is a negative, and they cancel each other out. So you get a null set. So your equations cancel each other out, and you can't make it. So yes, too much data, that's just bad data, okay? So, but I can pick the line up here. Again, you can clear out, or you clear or delete, either one works. Pick a different line, it spins a different way. Okay, but we want to go and spin it around the center line. Then when you check it off, you're right back where we were. We can now go back into the fillet command, 0.312. This time it will work just fine and dandy. Where it didn't work in 2D, it will work in 3D. So check that part off. Change the fillet to chamfer. Make sure it's set to a 1/16 of an inch, 45 degrees, bottom edge. And that's two ways of doing the same part. Either way is fine. You'll get where you like one over another, and that's fine. Okay.
Wait, what's the one for the dimension? All 0.312.
Yes. Okay. Let's go get those questions answered. Okay, put your full preview on. Right. There it goes. Okay, and then size 0.312.
Oh.
There you go. So help set the preview. What's the fix? Easy peasy now. Better? Okay. All right. Yes, sir. 0.065. Okay, while you've got this on your screen, before we move on, let's talk about how you're going to submit for grade. Okay? And I don't know if I can put a grade in before you submit. In fact, I'm pretty sure I haven't. So I don't want you to submit this today. I'm going to have you submit this on Wednesday. But let's go ahead and make the file to submit. Okay? So this will let me show you a couple of things that are a little different about your interface with the view. Please don't wig out on me. It's kind of tricky, okay? What I want to be able to see on here is not only do I want to see the view, but I also want to see it a little different, okay? So I can get the information from you, Okay, so if you go up to your top of your screen in this little panel right here, where your view orientation cube is, everybody find that? Hit the down arrow. I'm going to turn off that dang cube because I hate that cube. I don't. You can like it. I don't like it. Okay, so when I look at this, we've talked about these boxes here, right? They're all pretty benign, pretty easy to use. Then we get down here, there's 4 more. This first one is for a single view screen. That's what you're in right now. You see it in one spot. Click on the second one. Okay, now you can see it in 2 ways. Okay, so each one's independent of the other, but you move it, they're synced. Okay, so I got a front view and a top view. For this drawing, this is actually what I would want, is this submission. But let's keep going. Find your view orientation cube again, split it into 4. Go all the way over 4. And now you can get 4 independent views. So you can have a top, a front, and a right side. Okay. So this will be your screenshot. Now, some of you have figured out the follow the instructions for screenshot. There's an easier way. If you go down to your Windows icon in the lower left-hand corner, this little guy right here, and you just type the word snip, S, and I can't, it's on my other screen. It's called Snipping Tool. So just start typing the word snip. It'll let you open up an app. It's called the Snipping Tool. Okay, just like this. Okay, then when you get your view where you can see everything, all you have to do is hit New, and you can copy the entire page. You just hold your mouse button down and drag it. That'll be the view you have. Okay. Now you're not done yet. Okay, because you can share these, and that'd be no bueno. Actually, you'll probably do it anyway. So I don't care. There's a pen at the top. Type your name on it, or write your name. Just so I know it's you. You type with you write it with your mouse. You just get a pen, you write it with your mouse. And you can do different colors. I don't care what color you use. Okay, just put your name on there so it's not on your drawing. Okay, that way I know. Then go to File, Save As. It'll save as a PNG file, but just save this as RackPad. You can submit that on Wednesday for you guys. Okay, so on Wednesday there'll be a place for you to upload this into Canvas for your grade. Okay. But what I need to have at least the front view and the top view. Those are what I really need on there. And so that would be what you would get if you were just in the 2 views. This is what I need because this gives me the 2-dimensional stuff for the 1 class. Okay. Just to save as and give it a name and save it in your directory. So after you save your files, you have it. Okay. Good. What's that? Yes, put it in your 3D folder so you have it with it. And then RackPad, P-A-D. Okay, that's gonna be the easiest way for you to submit things, to keep things working. Okay, does that make sense? Not submit anything till Wednesday. You can start working on those assignments. So let's talk about those before you do the next one. Yes. Oh, so much. So we got 2 courses here. And they're different in each. So you want to go to the announcements. And this morning it says week 4. So here is what's going to be due in this course. This is the second course. You've got some geometric identification. Oh, I spelled shapes wrong. Oh, geometric shapes. Got to fix that. I'll edit that in a minute. Geometric terms, constraints, sketch models, and revolution. let's go in. I want you to look at those right now to take a minute, and then we'll do a break and come back. And then look at each of these to resolve your concerns over how much work this is, okay? So let's do that first. You go in here, go down to module 4. I should have gone the other way. I went the long way. Bear with. That's not what I want you to do. This is your reading.
1 through 6.
Yeah, pretty much.
1 through 4.6.
Yeah, it's not all of them. Yeah, just the 1 through 4.6. So they're not terribly hard. So let's take a look at geometric identification. If I hit the preview there, get an idea what's going on. What is that shape? What's that shape? You know, can you identify the name of the shape? Okay.
You put a lot of time into this.
I did. It was so much fun. I'm going to show you how to color your parts here in a little bit too. What? Oh my gosh. Yeah. So that's that one. Okay. We'll take you, if that takes you more than 2 minutes, slap your mother. Because she didn't teach you shapes. Okay. Don't tell her I said to do that. That would be bad. Okay. Let's take a look at the next one. So that one, you can probably do that one while you're waiting to do something. Okay, this one's not much more difficult. Okay, look, oh my gosh, there's the 5 shapes. Name them again. Name the parts of the circle. Do you guys know the parts of the circle? So if I asked you what F was, what would you call F? It's a chord, absolutely. What would B be? What's that area called? Quadrant. Yep, there's 4 of them. So quad is your clue. There's 4 quadrants. That's quadrant 1. What is C? Radius. What makes it? What's D then? You come down here. What do you think that would be? Sector. So if you're a Star Trek fan, they fly through the Delta Quadrant. If you're on Voyager, Alpha Quadrant's where Earth is. What's that? A is the tangent point, F is a chord. Yep. And G would be what? Segment. Yep, so this area D is your sector. Sector is part of the quadrant. Okay, so when we navigate our solar system, it's divided into quadrants. Because sun being the center, we divide out the solar system in 4 quadrants. Then Star Trek takes that and divides across the universe, with Earth still being the center. Oh, crazy. All right. So that one's not terrible, right? You guys can handle that. Easy breezy. There we go. So yeah, it should take you 5 minutes, right?
Hey, what do you call D again?
D. The I don't know, segment? Was it segment? I can't go back and look. Darn it, all. Let's see, do we do this one? That's one just did. Let's take it up here. Okay, this one is a little more terminology. There's 7 of them. Okay. A series of points equal distance from the center point. What would that be? Series of points with an equal distance from the center. If you got a bunch of points, they're all from the same center point, what would that make? Circle. Okay. A part of a line that is bound by 2 distinct endpoints. Line segment. Yep. I'll change that. It's one type today. I'll change it tonight. A line that intersects 2 planes. The intersection of 2 planes, what would that be? And then this one, the surface defined by 3 or more points. You know,
Just one.
well, it could be a plane. Okay, so let's find out where you're gonna find out how to answer these buggers, right? Okay, so if you get onto those and you're going, well, how do I answer these? Because you didn't really tell me the answers in class. That's because your book is in here too. Yeah, there's a book. Like right here, terms to know. And there's a book, ebook. Okay, so the terms to know, because we didn't really spend a lot of time on this before I got booted out. So sad. So the terms to know is really just flashcards. When you pull this up, you click on it down here. Oh, come on, get off this. Let's play. My cursor is not cooperating. That was working this morning. That's supposed to flip the card and so you can see it. There's also this text here, which is one I wrote. We're going to be doing this part next. Okay. But this has some of those terms in there as well. So you just need to go through the terms. Okay. You don't have to read the whole thing, but it talks about these different terms so you can work through them. The same terms that are in that Quizlet. Just go through the terms and the answers are there for you. Okay. Again, I'm trying not to make this like really a hard course. It's not supposed to be fun, but we do have to get it so you can get a job. That's the important part. I don't know why. Then there's this. These are constraints in CAD. We'll preview that one as well. There are 6 questions. Okay, they're not as overly crazy as you might thought. Okay, so if you have 2 circles on a plane that do not share common points, those would be called what? If you have 2 circles that don't have the same center point. We talked about this in class last week when we did the table. You don't want to go back and listen to that whole lecture. What's that? Not concentric. They're not, the word key term is not shared common point. So what's the opposite of concentric would be eccentric. Yep. So concentric means they're on the same normal axis or the same starting point. Eccentric means they're not. Okay. And yeah, these are all set to 1 right now. I'll change that here shortly. 2 lines that on a plane that are equal distance from all other points would be what? You got 2 lines on a plane and they are equal distance from each other, parallel. Okay, so you guys should be able to kick that out. And then, oh, what is that called? What would make that shape? This would be done with extrude. Yep. Okay, so that's extrude. What would make that shape? Revolve. Yep. And then freehand sketches are drawn. This is off your state test questions. When we draw freehand sketches, we want to keep them in proportion. So we don't draw a little teeny tiny nut over here and a giant screw over here and say they go together. That's not proportion. You want to keep them in proportion. A simple cylinder can be extruded or evolved. Is that true? You just did that. Can you revolve or extrude a cylinder? Yep, absolutely. Okay. And the last one here is everything starts with 2 sketch, right? Yes, everything starts with 2 sketch. Okay, that's for this course. Okay. Again, if that takes you, this should take you more than an hour this week, tops. Right? That's kind of my plan, is keep it simple but effective. That seems harder to say. Step over the first class then, the other one, the boring one. Let's take a look at what you're doing this week. Oh, nothing else. That's it. Oh, wow. So much work for you. Okay. Overwhelmed? All right. Let's take a break. Let's come back at 6 after the hour. Okay. 9:06. Dude, man. I gotta watch you. Is that how you win your races? You cut back the time? Question? Okay. I do recommend this, Bill, because everything in architecture is 3D. And so the part we just did, if you're designing like furniture or faucets or light fixtures, then you do the same stuff.
I hope so. Like, I know you only did. Okay. I arrived like 3 months ago.
Okay.
I hope it's not like, I can change. I can have this class like after the, no, not this one.
Architecture
Like for the
for next semester.
next semester.
Uh-huh.
Like,
Yeah.
not this two.
Uh-huh.
Like the third.
Well, there's a third class for this one, and you could do that as well because they're different times. So you could finish this one up, and you could do there's 3 architecture, there's 3. Uh-huh. And then there's a 4th called the capstone that you can take the 2 and bring together. So if you want to do like a custom like design a light, that'd be take the 2 classes and make 1 project.
Okay.
So yeah, we do have a 4th one for that too.
Okay.
Yeah, absolutely. And then the architecture ones, there's college credit.
Okay, we'll try to double line.
Yeah.
No,
Yo,
I could not access week 4 or something.
week 4.
For-
Really?
Yeah, that access denied.
Okay, let me pull that over here. Let's see if we can figure out what's going on there. It's always one more thing. Let's go take a look what's going on in week 4. Module 4?
Yeah,
Or they're not, is that what it is, the module?
yeah, the module.
Well, it's published. Are you going through the buttons?
Yeah,
Let's go look at your stuff. What you usually see what's going? This is what was telling me last week.
I go back here, there, I click on week 4. All right.
I think it's because I changed the name on it. So let me just fix that real quick. Hey, great one.
So man,
What do I do for you today?
teach me what is it, cat?
I'm gonna teach you how to draw a bike in CAD.
You design bikes in this
Oh,
program?
absolutely. Yeah, some pretty cool ones. Yep.
That actually is great.
Yep, you definitely can. Will you try, do a refresh on your screen, go up at the top of that little whirly gig? And see if we can get in there now.
This is access.
Really? Why? And you're a mechanical 2, right?
Yeah.
Because the mechanical 1, that one's, why is that blocked? All right, I'm gonna have to dig deeper, find out what's going on there. Can you click it? Can you get there through the modules on the side though? Okay, that's just weird. Okay, I'll spend some time on that and get that fixed.
Well, I got access to.
You, it's just 4 that's not,
Well, I have access to.
okay, oh, you do now? Okay. So many things to fix. And the architecture class is a little, I gave you 2 attempts on those. The architecture class has to kind of force their way in and open up all the quizzes, and they end up in the grade book, so now they're open for everybody. which is hurting the grades a lot. I'm not sure I'm gonna fix that. So I have to figure that out. We got it back here in just another minute. And I'm giving you unlimited attempts on these. On your state practice test, I'm waiting for everybody to finish that. Not everybody has done that yet. I'm not sure why, it's week 4. As soon as that gets, everybody's done it, then I'll switch those to a practice test and they'll come off your grade. But I'm waiting for everybody to do it once. And that's the state pre-test. Once everybody's gone through that, then I can switch that over. But I'm just waiting everybody to finish that out. And I'm not sure why it's taking so long. If you wonder if that's you, come see me and we'll chat about it. Hey, great one. Got 2 minutes to go. Griffin, is everything going good for you today, sir?
Yes.
Excellent. And if you look carefully at those week 4 assignments, some of them are not due until a week from Friday. What?
Don't tell me that. Don't procrastinate.
Just get them all done then. They're all due Friday. They'll take you an hour. Just get them done. Okay. I'm going to caveat that with number 5, 4.5. Okay. I'm going to talk about this in 30 seconds. Is everybody back? Anybody, neighbor missing? Okay, my friends, and I call you friends because you don't hate me yet. This is the 4.5 assignment that's due. This one I didn't show you before the break because I need you to be fresh and ready. What we have here is 3 distinct different ways of drawing. Okay. Now, all of these can be done in either AutoCAD or SolidWorks, but you need to reproduce these. And so I'm going to give you time on Wednesday. Man, you guys, I have seen this class way too many times the last 2 weeks. So on Wednesday, what we'll start the day off with is these. Okay. So if I want to know what that point was to start, what would you call that?
Origin.
That'd be the origin, yeah. Even though it's probably 0.5 and 0.5 is where that's going to start. What's the length of this line then?
3.
And how'd you figure that?
4 minus 1.
Yep. That would do it. So we just took that part. So you didn't produce this part to get it to the right size. All it's going to ask you on these, well, let's go look what's asking. I might change my mind on this one. I might have you just do this one right here. Okay, so if you guys will hold off, this one's more likely what you'll see on your state test. Okay, so on your state test, some of you ran across this in the practice for it. There's some drawings. You have to be able to tell what's the size of this circle, what's this point's distance from here. Let's focus on this one on Wednesday. and we won't worry about the other two because they all do the same thing. Okay, so we're gonna do this one in class on Wednesday. Okay, fair enough? So now there's one assignment, take them off your palette. Okay. And then I found out that the link is broken on the main page, so we've got to figure out what happened there. So I'll get that fixed. All of them are now set to unlimited tries. They were all set to 2 tries instead of 1, but that's okay. All right, so we're ready to do our next part of this drawing. And let me get that up here so you can see it. Maybe. Not. And that's this ball end right here. This one's a little bit more of a complicated drawing. It's not overly complex. There's just some thinking that has to happen. And that in itself can be problematic. If I want to go ahead and put your views back to single, again, view orientation, single panel, and go ahead and start a new file. New file, which is a new part file. And okay, this will be our ball end. This is also be done with the revolve and a little hole wizard work. Okay, because we want to get this little drill relief here. So when you look at a drill, there's 2 types of drills. There's a drill that comes to a point, and there's another one that's a flat, flattened off. That's a machinist drill. When we drill a hole into something, it's going to have this little end piece that is just there. We allow that on certain parts because it keeps the part from vacuum sealing up. So if I have a piece in there and it's the friction involved, I can make the air inside this cap allow it to be released. If you don't have that, things get tightened up there and then they vacuum seal and you can't get them out. Okay, so let's take a look at what's going on here. It looks like almost a semicircle, but we're going to cut it off here at the end. This note right here, S diameter, what do you think that refers to? What would you call it? Spherical. Yep, you see an S, you can hit spherical diameter or spherical radius. So if there's an S in front of it, that means it's a sphere. How do we make spheres on Earth? Do we make them? Pretty good. If you buy those little steelies for your marble set or your barbarians and your skateboards, are those perfectly round, perfectly spheres? No, we get them as close as we can. The only way to make a perfect sphere is up on the space station. We have to do it in an anti-grav area. You can simulate that on Earth by vacuuming out all the air, but you still have gravity. As long as gravity is involved, there's going to be imperfections. Okay, so there's a lot of manufacturing that takes place in the space station. Didn't know that. We do a lot of really high-end stuff up there. And Utah is, yes, sir.
Yeah, I remember my question.
Oh, good.
Is it possible if we can make animation of a Tesseract
Like
in cat?
the Avengers Tesseract?
Oh, like what?
The Avengers Tesseract?
No, like the 4D Tesseract.
Yes. You want to do that?
Yeah.
Okay. All right. Well, I mean, I'm just trying to figure out where you're coming from.
I Google it. It's pretty sick.
Yeah, okay. So for those of you who do not know what he's talking about, these are tesseracts. So it's the cube within the cube. It's what most of you start with your sketching. You do these little cubes inside the cube thing. Yeah, we can do one of those. How many of them do? How many sides do you want to do? I mean, we can go kind of crazy with it if you want. But yeah, we can do that. We'll do that. They're kind of cool little things. In fact, I'm thinking of what I want to do with that.
Like, can't you like animate it so it's like folding inside out of itself?
Oh, you want to do that? Yes, the guy upstairs can do that. That's a little more animation than what I do. We can try. It'll be a lot. It'll be a lot. We'll try. Okay, let's start here with a new sketch. Everybody with me now? Okay, new sketch. Start the sketch. Choose your plane. It doesn't matter on this one. Choose any plane you want. Any plane you want. Top, front, left, right, bottom. And this one. I don't remember which one. Okay, now like we did on the rock pad, we're going to start with a center line. So go ahead and draw a center line from the origin. I usually go up because it's natural for me to do that because it stays in a positive quadrant. But you could go down if you want, but I typically will go up. The more numbers I can keep positive, the easier the math for the computer is. What you don't want is you sit on your project and animate in a tesseract and the machine start to smoke, which is, I've been there once before. It's not a good thing. When your computer gets too hot processing, and that was just because I was being stupid, and I opened up 999 files because I wanted to see how many I could open, and it cost me a hard drive. Yeah, it did. The motherboard heated up and it melted and took out the hard drive with it. There's a limit to what home computers can do, okay? And I found it. So I could have done it easily at work on the network. If you're on network, you have a lot more memory space, but I was pushing the hard drive and the motherboard really hard, and I shouldn't have done it. I was just being stupid. Okay, we're gonna start this out. We're gonna do a circle on the center line, okay? Not the center point. Remember that center point's that yellow square. We don't want to lock things down to that. So we're just gonna do a circle. I'm gonna place it on the center line, but not the midpoint. Okay, just draw a circle there. Now it won't be anywhere near the origin, and that's fine. Okay, but the origin is what kind of keeps us so we know where we're at, and so we don't lose ourselves. And we're going to look at what's being asked here. Okay. I know the diameter of this is 0.562 is going to be my diameter for that sphere. So let's go ahead and give that a smart dimension on this circle. Okay, now we don't have to worry about the spherical thing. That's what happens when we revolve it. We'll get that with the revolve. Then we got to look at what this number right here is. This 0.49 is in parentheses. Okay, whenever you see a dimension in parentheses, it's called a basic dimension. They're meant to be field verified, which means there's a lot of allowance. It could be 0.5, it could be 0.48. It's just what happens is what happens. And a lot of that will be a result of the grinding that takes place to flatten this bottom off. So when these are built, they'll be done in a mold, and then they'll go to a grinder, and they'll flatten this bottom part off before they drill. It's probably the least efficient way of making these, but it's what we do. So this is an approximate dimension, okay? But when they use it, because it makes our life a little bit easier, hopefully, okay? And I'll show you what that means, because this one's absolute. This 0.375 is an absolute value, needs to be that. This is an approximate, okay? Okay, so here we go. In order to dimension a circle and place a line, I can't pick a point on the edge of the circle. If I try to dimension, I'm just going to get this value again and again and again, because it just keeps circling around. So in order to fake it out, we're going to go to the center line. I'm going to start at the top of the circle. There should be a yellow diamond. That's a quadrant point. And just drag a horizontal line off the quadrant that's tangent. So this line is tangent. That little circle with a line, a little cap there, is the tangent marker. Everybody get that? If not, stick your hand in the air. Yep, can do. So we do a center line, come to the circle and find the yellow diamond, Click on that, and then just drag a horizontal line straight out. Okay. Now remember, these center lines won't ever print, and they cannot become 3D objects. So you can draw as many of those as you want. Okay. Okay, now we're going to do an offset entities. And the value we're going to put in is the 0.49. Take off the chain. Okay, rarely will you use a chain. Okay, well, 60% of the time you won't. 40% of the time you will. It's kind of one of those days. Okay, then select your center line and go down. Pick down below. Okay, crazy, right? Now it's a solid line. Now it's part of my element. Okay, one more time. Offset entities. Set the value to 0.49. That's my target distance. I only have the dimensions added. I'm taking off the chain. I'm not doing bidirectional. I select the center line. It should go down. And now I've got a solid line. Whenever you offset a center line, it becomes a solid line. Oh, you crooked boy. Okay, hang on. Let's go fix you. Yeah. Oh, I grew up in Idaho. We did bad things. Okay, I'm gonna tell you this. You don't ever do this now. This will get you in so much trouble. I live by the Snake River Canyon, which is by Twin Falls. Evel Knievel could not jump this canyon. He tried and failed. If you put model airplane fluid on a cat's fur, and then you drop it from a high thing like a bridge, the friction and the static cling in the fur will ignite the gas. The cat fell to the river. It survived. The cat's alive. Okay, but it went down with a big flaming. Yeah, but yeah, cat fur holds a lot of static electricity in it. Don't do that. It's cruel. It's very, very cruel. Like I say, there weren't any rules in the 80s. It was a different world. Very different world. All right, we're going to do a measure. So I want you to go to the Evaluate tab. And we're just going to do a measure. And I want to measure from the endpoint of the new line I have to our intercepts. Now, you're not going to be able to do that, are you? Because there's no way to grab that intersection point. So in order to get a measure there, you have to go back to your sketch, add a new center line, and if you put your cursor right where the circle and the line cross, it will grab that point and you can get a center line. And what we're wanting to do is measure this distance, okay?
You go down or up?
Either way. Either way. I just want a dimension between the two center lines now. And when I do that, I get a value of 0.19. What is half of 0.375? Oh no. Quick, grab my phone. It'll help somehow.
My measure.
Is it? Mine did too. It's kind of weird. 0.375 divided by 2, which gives you 0.1875. Yep, that'll work. I'm in close enough position. Okay, so I'm just verifying that I'm going to have the right surface area. That's all we. You ever put Kool-Aid in your shower head?
What? Oh, I put the ramen noodle.
Yeah, that just smells bad. If you do like Kool-Aid or Jello, it'll turn your victim colors. College is amazing. College is fun. Okay, folks, now we're gonna get ready to fix this. We need to trim the crud out of this, okay? Because you cannot revolve a full circle. It won't revolve. Again, we've got the positive and negatives counteract each other. So what we're gonna do is we'll go into our sketch. We'll then go to trim entities. And I'm going to remove everything on the left side. So this is the trim the closest. Remove this side, the bottom piece, so it's flat now, and then pull this flat back. So it's just the shape I want. Okay. So even though it's going to be a circle again, or sphere, I need to trim it down so it just has the semicircle and a flat line. I'm looking for hands up.
Out of curiosity, that's the side.
So features.
Putting Ice Ice Baby on that.
I was, yes. Thank you for bringing the idiots fully back to life. So I'm going to do Revolve Boss Base. And it's going to ask me for a couple things because there's so much information on my drawing now, even though it doesn't look like much. I first have to tell it the axis is this center line. As soon as you tell it what the axis is, it'll make your sphere. If not, then pick inside the space here. But you could do, okay. Let me do it another way. Revolve. If it doesn't work, you can come down to select contours, and I can pick in this surface here, then tell it what axis to go around. Making progress on our drawing number 2 today. Okay, so once you check it off, you now have your sphere with a blunt end. We're then now put the hole in the bottom. Okay, so let's get you all here. What you need to do is go in your view orientation cube and get it where you can see the bottom. Okay, that means you see a little circle, big circle. Okay, so get both those up there. Okay, now what we're going to do is we're going to go into our feature tab where we're at right now. We should all be in the feature tab. And turn on the hole wizard.
Press it or the down arrow. Ooh,
Okay, what? I didn't understand that question. Okay, now if you don't have where you can see this flat surface, the holes can be put on a rounded surface. That's unlike anything else we do. Typically, you can only create things on flat surfaces of planes. The hole wizard is different. It'll put a hole anywhere you click. So you really want to pay attention to where you're at. It's kind of a nicety. And we're going to go ahead and set these up. What we have is we have a hole that is about almost 0.25 and only goes in 0.4. That's all the information we have. Okay, nothing more than that. We're not worried about threads. We're not worried about anything else. So where they come across here on our type, and we're going to go right here to straight tap. Actually, it's to go to hole. We're going to do the hole instead. And then the top row, just a hole. We're just making a hole. So click on that one right there. Top row, first one on the right. Top one, first one on the right. Yep, just the hole. Just make a hole. Now, yes, you can do these with just a circle and extrude, but if you do that, you got a flat bottom. And then you're likely to not ever get this thing off of the handle when you put it on there. It's going to fuse to it. And we don't want that. Okay, so let's look at our sizes. We've got all drill sizes at our beck and call. We need to make sure an ANSI inch. Again, ANSI stands for what?
American book. What if we do metric?
Oh, American National Standards Institute. If you're in metrics, your ball is about the size of a Volkswagen. Yeah. So, yeah, we'll deal with that later. I don't want to deal with that right now. Yeah. Yeah, remember how to go make sure you're in IPS at the bottom right. Make sure you're checking that. You need to find out which computers have their templates screwed up and so get this fixed. Okay, let's look at the sizes and we scroll down. Don't get past the numbers. Those are all metric sizes. And we want to get close to 1/4 inch because we're looking at 0.249. So we're going to go find 1/4 inch is what I want you to find.
Oh,
It's to be a little bit larger, but that's okay. It's okay to be a little bit larger. So 1/4. Yeah, 1 divided by 4. Okay. All right, now it's not going to go through all, so change the through all to blind. And you're going to change the depth to 0.4. So blind 0.4. Then take the check mark off of near side countersink.
wait, but how did you find that thing under it?
Change the depth to blind. So if it's through all, you won't have that. If you change it to blind, then you get a distance.
Like 6'9".
No, 0.4. Then we do not want the countersink, so turn that off. So all we have is a 1/4 inch size hole going in 0.4 inches. That's all we want. Okay. Then we go over here to position. Click on the position tab. Come over and find your flat surface. Click it once. And you should see the origin. Then you put your hole right on the origin. And as soon as you have that done, you hit the green check mark. And you've got a hole in there. Okay, now we need to look at something a little different. Is that a hand? Okay. Don't go anywhere. This semester, it kills me. We then work with silicone. I mentioned this before. The day we do silicone work, wear clothes that if they're destroyed, you won't cry. Okay? Because if you get silicone on your clothes, you're not getting it out. It's there forever. Okay? Okay, now, if you'll go back up to the top where your views are, we've got a zoom to fit. That just makes it fit your screen. There's a zoom area, so I could say, just zoom up on that, and then go back to zoom to fit. There is a zoom previous, which moves you back. If you've zoomed in, you can't remember where you're at, back up one. Then there's this guy. This is your section view. Everybody click on section view. Now, when you do that, it's going to cut right down the middle of whatever plane you're working on. So if you're on the top plane, it's going to look like this. Or the back plane will be like this. Okay? In this case, I'm here. Now, there's an arrow and there's an orbital arrangement. You can tilt how it's cutting. So you can analyze it that way. You can also grab the arrow and uncut it, or back it over through it to see what's happening as you're taking dissections through your part. So you understand what's going on in there. If you keep going, it will simply disappear and leave a shadow. So again, you can bring it back by just sliding that arrow. But this allows you to track what's going on the inside of your part, especially when you work on your lightsaber and you're trying to figure out where the wiring's going to go. How do you get the wiring in there? Where's the wiring going to be at? How are you going to keep it from getting pinched? And how you get that all to work out right, okay? So the section tool allows that. And again, you can set in absolute values. And you can just drag it to where you want it to be. You can rotate it, look at it from different angles. It's just a heading tool. When you're done, you just hit the X and you're out. It's just an on-off. It doesn't affect the drawing at all. Okay? But you need to be aware of that as we're working. Okay? Okay, this needs to be saved in your file as ball end. Please put the end on there. Had problems in the past. Ball end.